Now we are in part 3 of our horizontal asymptote series, and we are exploring the case of a rational function where the degree in the top is less than the degree on the bottom, and what kind of horizontal asymptote it produces. And we're going to illustrate this with a particular example. So let's let, for the purpose of this illustration, f of x equal 2x squared minus x plus 3 all over 3x cubed plus x squared plus 1. So this top is my p of x, which is a polynomial, and this bottom is my q of x, which is a polynomial. Notice that the degree of p of x equals 2, which is less than the degree of q of x, which equals 3. Okay? What we're going to do is we are going to multiply the top and the bottom by 1 over the highest power of the denominator, or 1 over x raised to the degree of q of x. So what that means in our example is we're going to multiply the top by 1 over x cubed and the bottom by 1 over x cubed. Remember, this is always legal, provided I do what I multiplied to the top is the same as I multiplied to the bottom, because that's the same as multiplying the whole by 1. And of course, that's provided x is not equal to 0. Alright, so let's see what effect this has if I multiply the top by 1 over x cubed and the bottom by 1 over x cubed. I'm going to have to distribute it to every term, so I get 2x squared over x cubed minus x over x cubed plus 3 over x cubed. The bottom will give me 3x cubed over x cubed plus x squared over x cubed plus 1 over x cubed. Alright, let's reduce this and see what it gives us. My top becomes 2 over x minus 1 over x squared if I reduce my powers of x, plus 3 over x cubed. The bottom, that becomes 3 plus 1 over x plus 1 over x cubed. So this is another form for my rational function. Now remember, to find the horizontal asymptote, we want to explore what happens to f as x goes to infinity or x goes towards negative infinity. Now what we learned in the previous videos is that all of these approach 0 as x goes to plus or minus infinity. 1 over x and 1 over x cubed also approach 0 as x goes to plus or minus infinity. So the top goes to 0 and the bottom goes towards 3. So the entire expression, or my rational function, goes towards 0. And so what we have is y equals 0 is a horizontal asymptote for f. And we could do another example where the degree on the top was smaller than the degree on the bottom, and we would multiply the top and the bottom by 1 over x raised to the degree of the bottom, and we would reduce all of our fractions, and we would send x off to plus or minus infinity, and we would discover again that the top goes to 0 and the bottom will go to the constant that sits in front of that highest power in the denominator. And so what we can conclude, if the degree on the top for any rational function is less than the degree of the bottom, I mean strictly less than the degree, so not equal to, then, and this is the rule, y equals 0 is a horizontal asymptote for f of x equals p of x over